Topic 10 Circles. First lesson Arcs and Sectors. So, our main objective is to calculate the length of an arc when the central angle is given and in degrees and radians. And the second objective is to calculate the area of the sector and the segment. So these are the main objectives. First, let's discuss some of the definitions. So all of you know what is the radius of a circle. So the radius of a circle is the distance from the center to the boundary of the circle. When we talk about the diameter, it's the distance. You can say it's 2 times the radius. So we can say the diameter is actually equals to 2 times radius. Now, what is a central angle? What is minor arc? What is major arc? Now look at this diagram. Here we have the center P of the circle. Here there's a point A, there's a point B. Now, if you go from point A to point B, this you can say this part of this boundary is called the minor arc. Clear? If the you can say if this part of the boundary is less than 180 degrees, it is called the minor arc. This is the whole boundary of the circle. If you take a part of the boundary of the circle, let me show it with a different color. If you take a part of the boundary of the circle, this is called the minor arc when it is less than 180. This is called the major arc when it is more than 180. Clear? Okay, now what is a central angle? An angle whose vertex is at the center of the circle. So if you join this point A with the center here, and if you join B with the center, so this angle is called the central angle. So any angle whose vertex is here in the center is called the central angle. Now, when we say measure of an arc, that means that what is the measure of the central angle. For example, if this angle is, let's say, 110 10 degrees, then what will be the measure of this arc? It will be the same 110 degrees. So you can say that the central angle and the measure of arc have the same value. Okay, now why this arc is mentioned like written like this, a arc AB, and why this one is written as ACB and with this symbol. Okay, when your arc is a major arc, now what is a major arc? This is the major arc because it is more than 180 degrees, right? If you say 180 degrees, so it will be the half of the circle, semicircle. So this side will become 180 and this side will become 180. So when an arc is less than 180, we write it with we call it minor arc. We write it with 2 letters. And when an arc is more than 180 degrees, we call it a major arc and we represent it with the 3 letters ACB. Is that clear? Okay, let's discuss some more definitions. Now, here's another one. It says, what is the minor? What is the minor sector and what is the major sector? Remember, when you make a central angle, this is the central angle, right? So when you make a central angle, you have actually two central angles here. One central angle is smaller and the other one is the bigger, right? So any a sector is, you can say, area inscribed in a minor arc with the two radii. As you can see here, this is one of the radius, this is another radius, and this is the minor arc. So the area or the part of this circle is called the minor sector. And this one, because it has the major arc, clear, with the two radii, so it is called the major sector. What is a major segment and what is a minor segment? When you draw a chord in a circle. Now, what is a chord? Chord is any line that goes from boundary to the other side of the boundary. So this is a chord, right? You can draw it over here, you can draw it here like this. So a chord, it divides the circle into two parts. The bigger part is called the major segment and the smaller part is called the minor segment. In this lesson, mainly you have to find the area of the sector, whether it's major or minor. You have to find the area of the segment, whether it's major or minor. Then they will ask you to find the arc length. Clear? So let's discuss now what is how can we measure an arc. As you can see here, it's written. Let me highlight okay, the measure of an arc is equal to the measure of its corresponding central angle. So whenever they ask you, either find the central angle or the arc measure, so it's the same thing. For example, let's say if they want me to find what is the measure of arc KL. Let's say this angle is this central angle is 25 degrees, right? So what will be the measure of arc KL? So arc KL, the measure of arc KL will be the same as the central angle 25 degrees. Okay, now if they ask you to find the, let's say here they said the arc JM. So it will be the same like the angle that is here, the central angle that is here. So that's why you can say the arc measure and the central angle, it's the same thing. Is that clear? Congruent central angles intercept congruent arcs, and congruent arcs are intercepted by congruent central angles. The same thing. That means that if you have over here, let's say, let me erase all of it here, because these two, look at this, these two are equal. So their central angles will also be equal. Clear? Now look at this example. It says what are measure arc AB and measure arc ACB. Now where's arc AB? Look at this here. The central angle is 95. That's why the measure of the arc AB will be 95 degrees. Now to find arc ACB, ACB is this one, right? The bigger one. So how we will find it? Because the total angle in a circle are 360. So you can say if you subtract from 360 95, the remaining angle will be 285. So you can say that the sorry 265. So this central angle is 265. So the measure of arc ACB will be 265. Is that clear? Let's all try it. Question here, it says use this circle. What is the measure of arc XZ? Now where is arc XZ? Here is arc XZ. This one is arc XZ, right? Okay, now what is its measure? It's the same as the central angle. So what will be the measure of arc XZ? Let me write it clearly. So it will be measure arc XZ. It will be 115 degrees. Now, what is the measure? I'll solve the second part with the blue color, XYZ. Now, they are talking about this one because the total angle in a circle are 360. So, from 360, subtract this 115 to know the remaining part of this angle. Okay, so 10 minus 5 will be 5, 5 minus 1 will be 4, and 3 minus 1 will be 2. So, the measure of arc XYZ, it will be how much? It will be 245 degrees. Is that clear? Okay, next we have how do we find the arc length? So here is the formula for the arc length when we are given the angle in degrees. Remember, you have two formulas for finding the arc length. One is when the angle is given in degrees. For example, if this angle is, let's say, 30 degrees. So how will you find the arc length? The arc length usually we represent it with the letter L, small l. So it will become 30 over 360 times it by 2 pi r. And you will put all of it r. The radius will be given. Let's say the radius is 12. So this r will be replaced by 12. So you can write over here 12 and then you will put all of it on the calculator to get the answer. Similarly, for this one, if they ask you to find the arc length when it is given, when they will give you the angle in terms of radians. So whatever the angle will be, we have represented it with the theta and you will times it by the radius and it will give you the arc length. Okay, then we have here, how do we find the area of a circle or the area of a sector. I think most of you know that how do we find the area of the circle. This is the formula for finding the area of the circle. It is pi r squared, right? And if I want to find the area of a sector, this shaded part is called the sector. As I told you, it has an arc with two radii. So this is the sector. It's like a cheese, a piece of cheese. Okay. Now, how do we find the area of the sector? We use this formula that says theta over 360. Now, what is theta? Theta will be the angle that will be given here, divided by 360, times it by pi, times it by r square, whatever the radius will be given, you will square it and it will give you the area of the sector. Next, how do we find the area of a segment? Now, if we do not have a direct formula for finding the area of the segment, to find the area of the segment, we say area of the sector, means we find the area of this whole shaded part, and then we subtract from it the area of this triangle. Okay, now what is the formula for finding the area of the triangle? It is half of r squared sine theta. Theta is the angle that is mentioned here with the green color. Okay, then we find the area of the sector using the same formula that I just explained here. And then we subtract both these answers. Means the answer for this one, what, for example, let's say the answer is 70.5, and let's say the answer for this part is 15.7. So what will you do? You will subtract 15.7 from this answer to get the area of the segment. So this shows that we do not have a direct formula for finding the area of the segment. It's going to be a 2 or 3 step problem. In step 1, you will find the area of the sector. In step 2, you will find the area of the triangle. And then in step 3, you will subtract them. Clear? Now let's solve some questions from the book. Here, the first one, it says, in a circle with radius r, what is the length of an arc that has the measure 80 degrees round to the nearest tenth? Now, what is the formula for the length? So this is the formula for the length. Length equals theta over 360 times it by 2 pi r. Now let's substitute the values into it. What is the angle? It's 80 degrees divided by 360 times it by 2 times it by pi times it by r. Now what is the radius given? It's given 4. Now you will put all these values into the calculator to get the answer. So let's find. So here is the answer. The length will be 5.6 units. Here is 2b. It says, in a circle with radius 6, what is the length of an arc that has a measure of pi radians? Now, because the angle is given in pi radians, I mean in radians, that's why you have to use the formula for the radians. So we want to find the arc length. So length will be equal to, the formula is theta r. Theta is the angle, so the angle is given pi times what is the radius? The radius is 6, so you can say it's going to be 6 pi, and if you turn it into decimals, it will become 18.6 units. Clear? So this will be the answer. Let's see, what do we have next? Here, try it number 4. It says, what is the area of the sector? They wrote here each sector because there were 2 parts. I'm gonna solve only the first one. So what is the formula for this one? And the formula for the area of the sector, let me write it for you. It says area equals theta over 360 times it by pi r squared. Now better pause the video here, put the values into this formula. What is the value of theta? It's 360. Okay, sorry, it's 165. So you will put 165 in place of theta, r will be replaced by 3, and then put all of it on the calculator to get the answer. Here is the answer. If you leave it in the form of pi, it will become 33 over 8 pi. If you change it into decimal, it will become 12.95. Next, we have, what is the area of the segment? As I told you, there is no formula for finding the area of the segment. So let's do it step by step. So here are all the steps. Step 1, as you can see in this step, area of the sector. First we will find the area of the sector. It's 90 over 360, times it by pi, times it by 10 square. So finally we get the answer 25 pi. In step 2, you will find the area of the triangle. What is the formula? It's half times radius squared. That will be 10 squared, sine 90 degrees, and finally the answer is becoming 50. In step 3, to find the area of the segment, the shaded part, you will subtract both these answers. So it will become 25 pi minus 50. Final answer is becoming 28.5 feet squared, right? Let's say a girl, she does not want to do all of this step by step. She can write directly like this on the calculator. Like this is the area for the sector, and this is the area for the triangle. So directly you can put these two areas in the brackets and it will give you directly the answers 28.5 feet square. So it's all up to you. You want to do it step by step. I think step by step is easier than writing all of it on the calculator, because maybe by putting so many values at the same time you will make a mistake. So better do it step by step. Here is the summary of the lesson, that you need to memorize these two formulas, this one and this one. Uh, if you are finding the arc length in degrees, I mean, if the degrees are given, then you will find the arc length using this formula. If you are given the angle in radians, then you will get the arc length using this one. Clear? Okay, and here is the formula for finding the area of the sector, and then we have the area of the segment. Clear? Let's start solving questions from the lesson now. So here is question number 16. It says, how long is, what is the measure of the arc FE? Here is arc FE, this one. This is arc FE. So how will you find arc FE? It's already mentioned, as I told you, the central angle is the same as the arc measure. So the measure of arc FE, it will become 100 degrees. To find arc CE, so where is arc CE? This is the arc CE, right? So how will you find this arc CE? Now this one is 90, but this one is 90, right? But we don't know how much is this one. So it means in the first step, we have to find how much is for this part. Okay, as you can see here, this arc is 50, so this one will also be 50. This angle is 90, this angle is 100, but we don't know how much is this one. So can we name it X? And this one will be the same as X, because they put these symbols to show that both of them are the same. So to find the value of X, you can say 50 plus 50 plus 90 plus we have X, and plus we have 100, and then we have plus another X. All of these, if you will add them, it becomes 360. Now this X, this X and this X, keep them on the left side, so it will be X plus X2X. And if you add all these numbers together, it becomes 290, right? So if you move this 200, I mean, let me write over here, this is becoming 290. So if you take this 290 to the other side, so it will be subtracted from 360. So 2x will be equal to 0, and 16 minus 9 will be 7, and we have 70. So that means now divide each side, divide here by 2 and divide here by 2. So it will give us the value of x equals 35. Clear? Now to get the value of this one, let's erase all of it because you understand how to solve it. So the value of x is becoming 35. So if this one is 35, if this x is 35, how can we get the measure of arc CE? Because the arc CE is from here to here. So it will be 90 plus 35. So the final answer will become 125 degrees. Clear? Okay, let's see what do we have next. Here they said find each arc length. Please remember there's a difference between arc length and arc measure. Okay, and leave your answer in terms of pi, means no need to change it into decimals. Arc length, now because the angle is given in degrees, that means I have to use the formula that says arc length S equals, okay, by the way, I was telling you that arc length is we write it with a small l, but I noticed that in your book they have written it with the letter S. So we will say arc length S equals theta over 360. Let's write the formula. It's theta over 360. So what is the value of the angle? It's 110 over 360, times it by 2 pi r. 2 pi r, the radius is 8. Now you put all of this on the calculator and write the answer, but keep your answer in pi. Let me find what is it. So when you put all of it on the calculator, the answer is becoming 44 pi over 9. Next, we have, like it says, find the area of each sector round to the nearest tens. So they want us to find the area for this shaded part. So what is the formula for finding the area of the sector? Area of the sector is theta. Theta means the angle. So what is the central angle? It's 52. So 52 over 360, times it by pi, times it by r squared. So what is the value of the radius? It's 12. This is the radius. So it will be 12 squared. Now put all of it on the calculator to get the answer. So here is the answer for this question number 22. Next, they are saying find the area of the segment. To find the area of the segment, as I explained you here, you can do it in one step or you can do it in three steps. Step 1, find the area of the sector. Step 2, find the area of the triangle. And step 3, subtract them. So better pause the video here and solve this question on your own. Here is the answer for this question number 24. This is step 1, area of the sector. This is step 2, area of the triangle. This is step 3, area of the segment. Subtract both the answers. Now here in this question, question number 26, they said the length of arc ABC is 110 feet. What is the radius of this circle? And round to the nearest tenth. Now look at this. This length is given, not this one, the smaller one, AC. ABC means this major arc. So the length of the major arc is given and they want us to find the radius. Remember, sometimes it's like a not a direct question. So if we write the formula for the arc length, it is S equals theta over 360 times it by 2 pi r, right? Now they here the radius is not given. The radius is not given, but the arc length is given. So you can substitute the value of arc length, this 110, in place of S. But what will be the value of theta? Because this arc length, this one is 110, but the measure of this arc is not given, means the angle that is the central angle for this arc, it's not given. So how will you find that central angle? So you will subtract this 54 from 360 to know the angle that is for the arc ABC. Is that clear? So 10 minus 4 will be 6, and here it will be 0, and so it's 306. Now I will use this angle 306 for this to solve this question. Clear? So you can write over here what is the arc length? It's 110 equals what is the angle? It's 306 over 360 times it by 2 times it by pi times it by r. Clear? Now because we are trying to find this radius, leave it alone, but multiply all these together to know what will be the number that will replace all these three numbers, all these, I mean 5 numbers. So it will be 110 equals 5.338 times it by the radius. If you put all this one onto the calculator, you will get 5.338. Now we want to make this r alone. So what can we do? Divide each side, divide this side by 5.338 and divide this side by 5.338. So what will happen? This one will cancel this. So we will get the value of the radius, that is becoming 20.6. Okay. So this is how you will get the value of the radius. Be very careful whenever you are using any formula for the arc length. You have to write here the angle or the measure of the arc, or you can say the central angle of the same arc. You cannot use this 54 over here. Is that clear? Okay, next. They said an arc has a central angle, this one of 2 over 5 pi radians, and the length of and a length of 6 pi. What is the circumference of the circle? They want us to find the circumference of the circle. For finding the circumference, C equals 2 pi r. We need the radius. But here in this question, they have not given us the radius. So it means your step one will be to find the value of the radius. Then you will find that value of the radius into this question to know into this formula to find the value of the circumference. Clear? Now to find the value of the radius, because the angle is given, the central angle is given in terms of radians, so we will use the formula S equals R theta. Now what is the value of the length? It's 6 pi, so S will be replaced by 6 pi. R, the radius is given in terms of the radius is not given, so leave radius. And what is the angle given in radians? It's 2 over 5 pi. Now what can we cancel from both sides? We can cancel this pi from both sides, and to move this fraction to the opposite side, so it will be flipped, so it will become 5 over 2 equals r. So the value of r will become 3 5 3 are 15, so it will be, the radius will become 15. Right? Now what most of the students they do, they quickly, they do not realize that actually they have to find the circumference. They circle this b part here. No, we are trying to find the circumference, so you replace this r by 15, so it will become C equals 30 pi. So this will be the correct option. Is that clear? Let's see, what do we have next. Here it says find the length of an arc subtended by an angle of 7 pi over 4 radians in a circle of radius 20 centimeters. Now length of an arc, that means you have to use the formula for the arc length. The angle is given in radians, this is the radius. Put all the values into the formula and get the answer. Better pause the video here and solve this question on your own. Here is the answer. By the way, they can ask you to leave your answer in terms of pi, or give your answer correct to one decimal place, then you will round this. So because if you round it to one decimal place, this 9 will become 10, so you will carry that 1 over here, so final answer will become 110.0 centimeters. Clear? Okay, next we have, here they said what is the diameter of this circle T. For finding the diameter, first you need to find the radius. Better pause the video here and solve this question on your own, and then play the video to check your answer. So here is the solution for this question. First you will use the formula for the area of the sector, that is theta over 360 times pi r squared. Because to find the diameter, we need to find the radius first. Okay, then I substituted the values. This is the sector area 64 over 5 pi. Then you can cancel pi from both sides, and then move this fraction to the other side, so it will be flipped on the other side. And finally we are getting r squared equals 64, and this will give us the value of r, because you will take the square root of both sides, so it will give you the value of the r, that is 8. Is my question done? No, because I found the radius, I didn't find the diameter. How do we find the diameter? Diameter is always 2 times the radius, right? So it will become 2 times 8, so the final answer will become 16 units. Is that clear? That's all for this lesson. Hope you understand it.